You've heard the term big data, right? It's everywhere. It sounds, well, huge and maybe a little intimidating. But what is it, really? Today, we're going to cut right through all that noise. We'll break down the massive challenge it presented, uncover the totally ingenious solution, and see why it has completely reshaped our world. So, to really wrap our heads around the scale we're talking about, let's just start with one company, Walmart. Every single hour, they process over 1 million customer transactions. Think about that. Not per day, not per week, every single hour. Or how about this? Let's look at social media. Every day, platforms like Facebook are just flooded with our photos, our posts, our updates, adding up to 10 petabytes of new data. And to put that in perspective, just 1 petabyte is 1,000 terabytes. It's a truly mind-boggling amount of information being created literally around the clock.
And here's the thing. It isn't just big corporations generating all this data. We are, all of us. With over 5 billion people using mobile phones for calling, texting, browsing, every single tap, every single call creates another drop in this ever-growing digital ocean.
So when you combine all those numbers, you start to see that this isn't just a trickle of information. It's a relentless, high-speed flood, a modern data deluge that our old systems were just, well, they were never built to handle it. Now, this whole phenomenon, it has a name: big data. But what's the actual tipping point, When does regular data become big data? At its core, big data is basically any collection of information that is so large, so fast-moving, or so complex that it becomes almost impossible to deal with using traditional tools. We're talking about everything from your social media posts and sensor readings to massive financial transactions. To try and make sense of this chaos, experts came up with this really handy framework, what they call the 3 V's. First up is volume. That's the sheer scale we've been talking about. Next is velocity, the incredible speed at which it's all being created. And finally, you have variety, the fact that this data comes in all shapes and sizes, from neat, tidy databases to messy, unstructured text and images. But, the story didn't stop there. As we understood more, a couple more V's got added to the list. Variability points out that these data flows can be super inconsistent and unpredictable. And then there's veracity, which asks a really crucial question about data quality. I mean, after all, just because you have a lot of data doesn't mean it's all accurate or trustworthy, right? And this presents a huge problem. Having access to an ocean of data sounds amazing, but if you can't store it, trust it, or make any sense of it, then it's all just useless noise. This is the fundamental challenge of big data. For pretty much any organization, this creates 4 massive headaches. First, storage. Seriously, where do you even keep all this stuff? Then, processing. How can you possibly analyze it fast enough for it to be useful? Then, analysis. How do you find that one valuable needle in a continent-sized haystack? And finally, a big one, security. How do you protect all this sensitive information? Faced with what seemed like an impossible task, the tech world really needed a whole new way of thinking. The old methods were breaking under the strain. And this necessity sparked a revolution in computing, a revolution that was born at the very companies that were drowning in data first. And this leads us to the hero of our story, an open source framework that was purpose-built to tame this digital dragon, a project called Hadoop. Hadoop's brilliant idea was to stop trying to build one single, gigantic, and ridiculously expensive supercomputer. Instead, it linked together thousands of regular, off-the-shelf computers, what the pros call commodity hardware, and got them all to work together as one cohesive system. It didn't just solve the problem, it distributed it. Its origin story is actually pretty fascinating. The core concept came from a groundbreaking paper that Google published back in 2004 about a model they called MapReduce. A year later, 2 developers, Doug Cutting and Mike Caffarella, built an open-source version of it, and they named it Hadoop, after Cutting's son's little toy elephant. By 2008, it had become a top-level project at the Apache Software Foundation. Now, Hadoop's real power comes from 2 core parts working together perfectly. First, you have the Hadoop Distributed File System, or HDFS. The easiest way to think about it is like a massive digital library that, instead of storing a whole book on one shelf, it breaks the book into chapters and scatters those chapters across thousands of different shelves. Then you have MapReduce, the processing engine. This is like asking every single librarian to scan their one shelf for a specific word all at the same time. That's the map part. Then, one head librarian librarian collects and tallies up all their counts, and that's the reduce part. It's parallel processing on a massive, massive scale. Okay, I know that was a lot of technical detail, but why should anyone who's not a computer scientist care about distributed file systems and programming models? Why does any of this really matter? Well, by solving those core challenges of storage, processing, and analysis, technologies like Hadoop unlocked a whole new world of opportunity. All of a sudden, companies could analyze user behavior to innovate new products, they could make smarter decisions to improve efficiency, and ultimately, they could turn these massive, messy datasets into a powerful competitive advantage. Ultimately, the ability to manage and analyze big data has fundamentally changed our world. Tools like Hadoop gave us the power to find answers that were hidden in the chaos. And that leaves us with a final and maybe more human question to think about. Now that we can analyze almost everything, the greatest challenge isn't finding the answers, it's learning how to ask the right questions.